We will go for the last set of topic. No? So we've covered so far again. No? We are still on straight line motion. We are on, let's say, linear motion. And we are now on the third type, no? Which is called the accelerated motion. I will ask you to please mute your mic, no? For those of you who have not noticed. Mute your mic, please. So on our accelerated motion, we are going to illustrate this with a line again. So we will have a line, and we are going to slice the line here, divide the line. So let's say we divide it. That's the first segment. The second one, third, the fourth, and perhaps let's just extend this just a little bit, and let's have the last line. For example, this is our last value, and again, now we will call the different values there or points, So this is A, this is B, this is our C, D, E, and then probably your point F. Now, let's have this next value. This is our lengths. We will have there 3 meters. We have 5. We have maybe 6 meters. Let's say that's 9. And let's say this is 11 meters. I don't know. That's not 11. Let's say that's just around 6 meters. So next line is the time. So again, from every interval, it took 1 second for the object to travel. So 1 second lang na. From C to D, it took the object to travel 1 second as well. This is another 1 second. And this is another 1 second as well. Okay, now we are going to find our velocities there. So V1 is how much for the first interval? That's 3 meters per second. Our V sub 2,
5 meters per second.
5 meters per second. Our V3,
6 meters per second.
meters per second. And then next value V4,
90 meters per second.
V5, that's equal to 6 meters per. Now, what we will do, kindly mute the mic, please. We are going to get the difference in our values there. James, what do you call the difference of our velocities, James? James Dominic, what is our term for this value, the difference? James? Gail, what do you call the difference there, Gail?
As acceleration, sir.
As acceleration. How much is our first acceleration, Gail?
2, sir, 2 meters.
So 5 minus 3 is 2.
2
meters per second square.
second.
This is a small 2, it's a squared value. The next acceleration, Gail, is, so we can call this as acceleration 1. Our acceleration 2
is 1 meter, sir.
Acceleration 2 is
1 meter per second square.
Per second square. 3.
3 meter per second
So that's
squared.
another 3. No? And last value, Gail, is what?
-3, sir.
O man-negative. Nga negative, final minus initial.
Mas initial.
Minus 9 is negative 3. No? Very good, Gail. No? So, pwede gali ang aton acceleration nga negative. No? Pwede siya mag-negative. So, ano aton mahambal di? First is our velocity is not constant. No? Hindi constant aton velocity. And what else?
Ang acceleration, sir, hindi man constant.
Constant. But I will draw a line first. No? So, both of these values are not constant. No? Sorry, no? Yeah, let me delete. So, ang aton nga value is hindi siya constant. No? So, duwagid, no? So, again, how did we calculate our acceleration? Our formula for acceleration is
VF minus
F
V1.
minus BI.
VI.
Then we divide it
Divide time.
by the unit of time. No? So, our value, so actually aton for aton nga equation sa aton nga acceleration, ano gani aton definition sa acceleration?
The change in speed, sir.
So this is
And velocity.
called the rate of change, no?
In velocity.
No? Or velocity. But may nalipatan ako kaina, I missed the word, no? Per unit of time. No? Per unit.
Time.
So may time na sa denominator natin. No? So again, when we say per unit or rate of change, we simply subtract the two values. No? Now from this expression, we can also see that we can have, no? We can actually write our V sub F to be equivalent, no, to our V sub I plus, no, our A, and we multiply that with T. No? Now, where did we get that one? If you try to multiply A and T together, no, from here, no, and transpose V sub I on the other side, we will end up with an expression like this. No? So actually, we can, again, we can get it from here, where AT is equals to VF minus BI. Transposing B sub I on the other side gives you, no, the value B sub F eventually. No? Now, we have also an equation earlier, no, that says that velocity, no, is equal to, no, a value called S divided by time. No? And again, no, this is actually, no, what we term as average. So the V value here is what we call the average velocity, no, or average speed. No? Now, for example, no, when a car, for example, is traveling, you could never say that it will run, no, with such continuous value. No? Now, usually the average velocity is indicated by some kind of a bar, no, on top. No? So may bar kita na gina-drawing or ginasulat na sa babaw ya to indicate that it is an average value. No? Now, this average value could also be determined, guys. No? So V bar could also be written, no, as equivalent to VF plus V sub I. No? Then we divide it by 2. No? Just like when we get average values, we add and we divide them by 2. No? Okay. So this is also another way of writing our average velocity. Now, average velocity again is indicated by a V bar na expression. No? Okay. Now, with this expression again, now from this second expression that we have, we can also get, no, an expression for S. No? So S can be written as V bar T. No? So V bar V bar D. No? Any question from you? So we are going to transform this now in our later discussion. Okay, I think we have less than a minute to go. No? So when we are cut, kindly link again. No? We will be deriving some expressions here. So therefore, no, I want you to follow. No? Okay, so I think now we are cut na in a few minutes.